Hello students, welcome back to the Nazir physics classes. And presently we are doing rotational dynamics, and I have delivered many lectures on rotational dynamics, and it continues. Today, in last lecture, I discussed angular momentum, translational angular momentum. If your body moves about certain point, I found it is angular momentum. And the formula was L is equal to R cross P. And I gave you some examples also how to find the angular momentum of a moving body about some fixed point. But now I want to do the same thing again. मैं चाहता हूं कि मैं आपको बताऊंगा कि रोटेशनल एंगुलर मोमेंटम, इफ ए बॉडी रोटेट्स अबाउट एन एक्सिस, सेंटर ऑफ मास रेस्ट पर है. अगर इसका सेंटर ऑफ मास रेस्ट पर है तो मैं देखना चाहूंगा व्हाट इज द रोटेशनल, इट रोटेट्स अबाउट एन एक्सिस, हाउ मच इज द एंगुलर मोमेंटम ड्यू टू इट्स रोटेशन. So under the heading rotational angular momentum, rotational angular momentum, इसका फॉर्मूला क्या है? What is its formula? Rotational angular momentum का फॉर्मूला क्या है? How to develop a formula for rotational angular momentum? ठीक है, ओके. Let me take any rigid body. एक rigid body ले रहा हूं मैं ऐसे, और ये एक्सिस है, कोई भी एक्सिस हो सकता है. दिस एक्सिस में even pass to the center of mass, or it may be any other axis. So the body rotates about this axis with angular velocity omega. It rotates about this axis. I want to find its angular momentum due to its rotation. Body rotates and I want to find its angular momentum due to its rotation. So what I do is I take a mass point here, mi. Let this mass point be away from the axis Ri. So when the body rotates about an axis, every point inside the body, उनका क्या होता है? They move in circles. ये point ऐसे circle में घूमेगा inside the body. When the body rotates, every point inside the body move in circles with, okay, let me suppose vi speed. तो अब आप मुझे बताइए कम से कम इस पार्टिकल का क्या एंगुलर मोमेंटम है about this point या about this axis. So angular momentum Li is equal to इस पार्टिकल का जो अंदर सर्कल में घूम रहा है, दैट इज ओके. लेट मी राइट द बेस फार्मूला आर आई क्रॉस पी आई. बेस फार्मूला आर क्रॉस पी, मगर ith पार्टिकल पोजीशन एंड ith पार्टिकल मोमेंटम. सो इफ आई गो अहेड विद दिस, सो एल आई एंगुलर मोमेंटम ऑफ दैट सिंगल पार्टिकल inside the body is, it is ri cross pi is mi vi momentum. So if I go ahead, there is Li, angular momentum of that single particle, that is Ri cross Mi, and what is Vi? Velocity, that is Ri omega. V is equal to R omega, that I have already done. That is Ri omega. We can't write omega I because omega is the same for all the particles. So what should I write here? That is Li is equal to, so Ri squared. So it is Mi Ri squared, but Ri it is to be crossed with this. So यहां पर जस्ट ए मिनट, यहां पर मैं एक स्टेप में थोड़ा सा सिंपलीफाई करता हूं इस चीज का. सो इट इज एल आई मैग्नीट्यूड इज इक्वल टू आर आई. जब मैं क्रॉस आर आई को वी आई के साथ करूंगा, आर आई और वी आई वो परपेंडिकुलर है आपस में. सो इट इज एम आई बाहर लेकर के आर आई को मैं क्रॉस करूंगा वी आई के साथ, बिकॉज एक स्केलर है, क्रॉस तो वेक्टर का होता है. अच्छा, नाउ इसका मैग्नीट्यूड लेकर के, सबका मैग्नीट्यूड, इट इज एल आई मैग्नीट्यूड इज इक्वल टू एम आई. व्हाट इज दिस? आर आई वी आई. इनके दरमियान एंगल जो है वो 90 है, कि पार्टिकल मूव्स इन अ सर्कल. सर्कल का जो वेलोसिटी है वो रेडियस वेक्टर को 90 बनाता है. इट इज आर आई VI sine of, okay, sine of 90. So it is angular momentum is equal to MI RI VI. So it is also equal to MI RI. What is VI? That is RI omega. I am doing things for the ith particle, a single representative particle. So what is angular momentum? Li magnitude, that is MI RI square omega. Now I want to find total angular momentum, summation of all the particles, summation of all the particles. So its total angular momentum is equal to, what is this? Summation MI RI square. If you remember, it is moment of inertia and it is omega. That is the answer. So what we have done is that if a body, it rotates about some axis, its angular momentum is omega, that is angular velocity of the body about that axis, into multiplied to moment of inertia about this same axis, not about any other axis. It may not be on center of mass axis, it may be a different axis, लेकिन moment of inertia आपको निकालना है इसी axis के around, जिस axis के around ये body rotate कर रही है. That is all. So you have a simple formula: a body rotates, its angular momentum is I omega, moment of inertia into angular velocity, right? And you are finding the angular momentum about that axis, and the direction of the angular momentum is the same as the direction of the angular velocity in a simple case. In this case, the angular momentum has the same direction as the angular velocity, but that is not the general case. In special case, the angular momentum and angular velocity have the same direction. L and omega have the same direction, right? Okay, this is one part. Now let me go do some examples on this. कुछ examples करना चाहेंगे ताकि हमें understand होगा कि what we mean by rotational angular momentum. Rotational angular momentum. Examples. First example, अगर मेरे पास ये suppose एक रिंग है, ये रिंग है और ये इसका एक्सिस है, and this ring rotates with omega. इसका mass m है, रिंग का mass m है. So I want to find what is the angular momentum of the ring about this axis. अब सेंटर ऑफ मास रेस्ट पर ही है और ये एक्सिस सेंटर ऑफ मास के थ्रू पास करती है. जरूरी नहीं है अगर किसी और एक्सिस के पास भी पास करता हो तो एंगुलर मोमेंटम आप निकाल सकते हैं. व्हाट इज एंगुलर मोमेंटम? आई ओमेगा एज यूजुअल. L is equal to what is omega, the moment of inertia about this axis, center of mass axis, passing through the center of the ring and perpendicular to the plane of the ring. That is m r square and omega. Answer हो गया. अच्छा, अब मैं B इसी रिंग को लेता हूं, इसी रिंग को लेता हूं, लेकिन अब यहां से एक्सिस पास नहीं कर रहा है, मुझे चाहिए इस एक्सिस के अबाउट ये रोटेट कर रही है. रिंग इज रोटेटिंग लाइक दिस. इट इज रिंग, it is rotating like this. It is rotating not about this axis but about this axis. In that case, what is the moment? What you call as what is the angular moment? L is equal to again I omega. Omega is this, but I is not this. I is this. You have to find moment of inertia of this ring about the new axis this. So angular momentum निकालने के लिए आपको ये देखना पड़ेगा कि ये जो बॉडी है ये किस एक्सिस के अबाउट रोटेट करती है. उसी एक्सिस के अबाउट आपको मोमेंट ऑफ इनर्शिया निकालना पड़ेगा. तो मोमेंट ऑफ इनर्शिया जो इस एक्सिस के अबाउट है कितना है? आई. मोमेंट ऑफ इनर्शिया अबाउट सेंटर ऑफ मास एक्सिस एम आर स्क्वायर प्लस एम आर स्क्वायर. तो अगर अलग से निकालोगे दैट इज आई सी प्लस एम एच स्क्वायर. मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस, राइट? इट्स आई सी. सो इट इज ओमेगा. दैट इज एल इज इक्वल टू दैट इज एम आर स्क्वायर, moment of inertia about this axis plus mr square omega. That is L equal to 2m r square omega. खत्म बात हुई. लेकिन अब ये देखना है कि अगर अबाउट इस एक्सिस के अबाउट ये रिंग रोटेट करता है तो ऑब्वियसली आपको इस एक्सिस के अबाउट जो मोमेंट ऑफ इनर्शिया वो लेना पड़ेगा. अच्छा, थर्ड एग्जांपल. See, third example. थर्ड एग्जाम्पल से देखिए, रॉड लिया मैंने, ये रॉड और ये है एक्सिस, और दिस रॉड रोटेट्स अबाउट दिस एक्सिस लाइक दिस. ये है रॉड, तो मैंने नीडल यहां से पास किया है, इस एंड से नीडल पास किया है. इट रोटेट्स लाइक दिस. It rotates like this, and I had to find the moment of this what you call as angular momentum about this axis. It rotates like this. Length L है, तो length small l कर दो. तो बताइए मुझे, अगर इसका मास m है, बताइए what is angular momentum? I omega. L is equal to what is I? Moment of inertia about this axis of the rod. 1/3 ml square. Omega. Answer. That is all. डी. और एक एग्जांपल, अगर मेरे पास ये डिस्क है, ये डिस्क है और मैंने होल किया, इस डिस्क को मैंने, ये डिस्क समझो बोर्ड पर ही है, बोर्ड के प्लेन पर ही, मैंने इस डिस्क को यहां होल कर दिया इधर, और एक नीडल पास किया इस होल के थ्रू, वो एक्सिस बना, एंड इट रोटेट्स लाइक दिस. इट रोटेट्स लाइक दिस. ओमेगा से ऐसे रोटेट करती है. इस होल के अबाउट एक नीडल डाल दिया मैंने और ये रोटेट कर रही है. ये सेंटर है, सेंटर से यहां r/2 दूरी है, एक्सिस ये है, एक्सिस ये है. तो दैट मीन्स व्हाट इज मोमेंट ऑफ इनर्शिया अबाउट दिस एक्सिस? अबाउट दिस एक्सिस इट इज IC plus mh square, that is parallel axis theorem. So I is equal to how much is IC? That is 1/2 mr square plus m, what is h? Distance between the two axes, parallel axes, that is r/2 whole square. That is I equal to 1/2 mr square plus mr square by 4. That is I equal to, it is 4, 2 plus 1, so 3/4 mr square. So ये है moment of inertia about this axis. Now I ask you, what is the rotational energy in this, sorry, what is the angular momentum about this axis? What is the angular momentum of the body about this axis? This one. So what you write? Simple. L is equal to I omega. But what I? This I, not this. This I, because it's rotating about this axis. So L is equal to, what is I? 3/4 mr square. That is I into omega. Answer. That is the answer. D. I am giving you some certain examples so that you learn about the rotational angular momentum. A body rotates about some axis. What is this rotational angular momentum? I omega. But what I and what omega? I, the moment of inertia about that axis, about it rotates. ठीक? Okay. C. D. E. One more example. One more example. It's a rod here. Center of mass of the rod is this. It's an object moving with velocity v and mass m. It is O. My question is, what is the angular momentum of this object about this? O. What is the angular momentum of this object about this O? Object LO. That is mv को, मोमेंटम को आगे ले जाइए, ऐसे यहां से परपेंडिकुलर डाल दीजिए, डाल दिया. दैट इज L/2. तो इट इज mv L/2. दैट इज ट्रांसलेशनल एंगुलर मोमेंटम ऑफ दिस ऑब्जेक्ट. बट लेट मी सपोज दिस ऑब्जेक्ट हिट्स this rod, and this rod is like this. This object hits, and it hits this rod, and it sticks to the rod, and the rod moves, let me suppose, with a velocity of v dash, and it also begins to rotate now. This rod also begins to rotate. What is the angular momentum about the O again? About this O. The angular momentum about this O is, if the moment of this rotates about this, suppose the moment of inertia is I, and it rotates with omega, so angular momentum is I omega about O, because this v dash velocity passes through this point O, therefore translational angular momentum is 0. It is only enough the rotational angular momentum. Of course, when the body sticks here, the center of mass will shift a little upwards. It won't be at the center. It will be a little. It will shift towards the heavy mass side. But what is important is here, center of mass will not remain at the center. It will shift a little upwards. But what is important is there, the angular momentum is only due to rotation, not due to translation about this point, because velocity passes through this point. So this velocity will not produce any angular momentum about this point. It is only the rotation which will produce the angular momentum. That is, and this velocity of the center of mass, it is passing through the center of mass, so it is momentum. Mass into velocity passes through this point. Therefore, the angular momentum will not be produced due to the motion, this velocity. It will be produced due to the rotation about this point. So it is I omega. So in other examples, when we have to conserve angular momentum, we will say angular momentum before and angular momentum after. Angular momentum before the collision will be translational angular momentum this, and after the collision it will be rotational angular momentum this. That we will do separately. Okay. Another example. Another example of angular momentum. Now, see here, it's a body. It is a rolling body. It's a rolling body. It moves with forward velocity v. In case of rolling, the point of contact, this P, point of contact, it is velocity. Velocity of point of contact is 0. इस point का velocity 0 होता है. ये हमेशा आपको याद रखना चाहिए. Rolling में point of contact का velocity 0 होता है with respect to the surface on which it rolls. When a body rolls, see, when the body rolls, in that case, you must know the point of contact has 0 velocity with respect to the surface on which it rolls. That you must remember. Okay. And one more condition for rolling is the velocity of center of mass is r omega. Radius of the disc, maybe cylinder, maybe sphere, uska radius into omega, angular velocity. So the condition for rolling is the velocity of point of contact is 0 with respect to surface on which it rolls, and the velocity of center of mass is r omega. My question is, it is center O. What is the angular momentum about P of this body? Angular momentum of this body about P. First of all, the velocity v, it is translating also. The body is translating in the forward direction, so it has translational angular momentum. What is that translation angular momentum? That is mv, momentum of the body, into this r. What is the direction? R cross p, inwards. That is inwards. R is up, and wind r into momentum v, that is inwards. Also plus angular momentum about p is translational angular momentum, plus it is rotational angular momentum about O, that is I omega. That is the answer. So it has two angular momenta. One translational angular momenta and another I omega, that is rotational angular momentum, I omega. Right? Please, you just concentrate here. The angular momentum about P is first translational angular momentum, that is this, plus rotational angular momentum, that is I omega. Now, what is the angular momentum of the same body about O? About O, the angular momentum due to the velocity, due to this mv is 0, because the velocity passes through this point. Momentum passes through this point. So this v will not contribute to the angular momentum. It is only I omega. So the angular momentum about P is mvr plus I omega, and angular momentum about O is only I omega, because the velocity or the momentum of the body passes through the point O. Therefore, that will not contribute any angular momentum about O. So this was the lecture on rotational angular momentum, and I also combined translational angular momentum with it. You just concentrate on the lecture and do things about it, and also download the questions from the application. And don't forget to continue, don't forget to watch my lectures on the YouTube, and don't forget to subscribe to the channel Tantray Sir Physics Classes. Thank you.